So, properties of areas. Okay? So, ang goal natin dito is para magkaroon tayo ng background sa moment of inertia, because we will use that sa computation ng bending stresses natin for our beams. Okay? So, without further ado, tuloy tayo. So, there are seven properties of areas na gusto kong i-discuss sa inyo this afternoon. So, first is yung centroid of an area. So very basic na to, alam niyo na to. Yung centroid of an area is analogous to the center of gravity of a homogeneous body. So the centroid is often described as the point at which a thin homogeneous plate would balance. Okay? So kung saan nagba-balance out yung isang plate pagka i-hold up mo siya sa iisang point lang. Okay? So, pag sinabi nating centroid of an area, that is yung equation natin for that is just equal to yung total area times yung x distance ng centroid natin. And that is equal to yung integral of yung x distance ng differential area. X distance times yung differential area pala. Okay? So, in a much more expanded term, pagka yung these equations pala, yung may integral na yan, ginagamit yan kapag yung shape natin ay ang given ay yung equation ng line. Okay? Paghahanapin mo yung centroid ng area bounded by a line, so gagamit tayo ng integral. So I hope na hindi naman I hope I suggest na i-review niyo yung topics niyo sa integral calculus niyo. Okay? So dahil there is a possibility na ibibigay ko to sa inyong mga exams. So, the more expanded version ng ating centroid, equation for centroid, that is equal to yung total area times yung x distance ng centroid ng ating total area, that is just equal to yung summation ng product ng individual areas and x distances ng centroid ng mga respective areas na yun. Yung mga components yan. So, A1, x1 is plus a2 x2 plus a3 x3. Okay? So if your total area is composed of different siguro basic shapes, ganun. Kukunin niyo yung area 1 tapos yung distance ng centroid niya from the same reference point. Tapos yung si area 2 naman tapos yung x distance ng centroid niya from that very same reference point, and so on and so forth. Mamaya madi-discuss natin yung equation na to. Pero I think alam niyo na to kaya-kaya nyo nang maghanap ng centroid ng area. Okay, another one is center of gravity of flat plates. Same lang din siya ng sa centroid of area. Pero in this case, gagamitin natin hindi area kundi yung mga weight. Okay? So pag given yung total weight natin times yung makukuha natin yung x distance ng center of gravity natin by getting the summation of the weight times yung x distances ng centroids ng individual weights natin of individual components. Okay? So for example, meron tayong shape 1, shape 2, tsaka shape 3. Nandito sa figure natin. Okay? So kukunin natin yung weight 1 tapos yung x distance ng kanyang centroid from the same reference point plus yung weight 2 tapos yung x distance ng centroid niya from the same reference point, and weight 3 tapos yung x distance centroid niya from a reference point. So, makita natin, very basic. We will be seeing how to use these equations later. Okay? So, third is yung moment of inertia. So, this is also called the second moment of area. Okay? So, the moment of inertia of a beam's cross-section measures the ability of the beam to resist bending. Okay? So, pag sinabi natin moment of inertia, it is the ability of the beam or the cross-section to resist bending. Bending about the x-axis, bending about the y-axis. So the moment of inertia about the x and y-axis and the function y is equal to f of x can be found by integration using the following equation. So ito yung general equation natin in getting the moment of inertia of a certain cross-section of a certain area, that is equal to integral of y squared differential area. Okay? Where yung y squared natin or yung y natin, that is yung y distance ng centroid ng ating differential area. Okay? At ganoon din in getting iy or yung moment of inertia with respect to y. Kukunin natin yung integral ng x squared differential area times differential area where yung x natin, it is the x distance ng centroid ng differential area. Okay? So, yung differential area natin, that is equal to yung function times differential x or yung function times differential y depending sa orientation ng ng strips mo kung pahababa o pahiga. Okay? So, that is yung general equation natin in getting the moment of inertia. Pero, ang gagamitin naman natin usually dito ay basic shapes lang. Okay? Kaya, siguro magbibigay ako isang problem. Hanapin nyo yung moment of inertia of the area bounded by the function f of x. So, please review na din yung integral calculus. Okay? So, section. This is yung a brief introduction or explanation ng moments of inertia. So, pag sinabi natin moment of inertia with respect to x, yung section na, yung resistance ng cross-section natin to rotate about the x-axis. So, for example, we have this I section. For example, yung mga steel beams natin, di ba? Usually, yung shapes nila I, H, mga ganyan. Okay? So, meron siyang X and Y axis. Okay? Yung cross-section natin, ang tinutukoy natin dito, Ngayon, pag yung section natin magro-rotate about the x-axis, yan yung pinreprevent ni moment of inertia with respect to x. So, typical na nangyayari dito sa mga beams kung saan loaded siya sa kanyang top. Okay? So, for example, meron tayong beam dito. Side view ito ng beam, Side view ito ng beam, tapos niloadan natin siya ng point load dito. The tendency is, pag niloadan natin siyang ganyan, magbe-bend yung ating beam. Okay? So, medyo exaggerated to. Ang mangyayari, yung cross-section natin, yung perpendicular cross-section natin, hindi na siya vertical, pero habang nagbe-bend yung beam, yung mga cross-section natin nagro-rotate. Hindi mo makadraw ng Okay, exaggerate ko na lang yung rotated na Nagro-rotate yung ating cross-section. Okay? Okay, so kung imagine ito yung cross-section natin, pag nag-bend yung beam ng ganitong ng ganitong manner, yung cross-section natin nagro-rotate siya about the x-axis. Okay? So yun yung pinreprevent ng ating moment of inertia with respect to x. Kaya kung mahapansin niyo sa mga timber structures, okay, yung sa timber structures, yung mga studs natin ay yung longer part yung nakatayo. Okay? Hindi siya nakahigang ganun pero nakatayo siya. Okay? Because yung moment of inertia ng nakatayo mga studs ay mas malaki compared sa nakahiga na cross section. Okay? So that is yung moment of inertia with respect to x. Pag moment of inertia with respect to y naman, i-imagine natin yung section natin, it will rotate about the y-axis. So yun yung pinre-prevent ni moment of inertia with respect to y. Okay? So in most cases, nangyayari yan sa mga beams that are loaded sa kanilang side. So for example, itong beam na ito, this is yung top view ng beam natin, top view to ng beam natin, tapos niloadan natin siya ng force dito sa gilid niya, let's say load P. Okay? The tendency is magbe-bend siya ng ganito, tapos yung cross-sectional elements natin ay ganito na itsura niya. Mapapansin niyo, parang umiikot siya about its y-axis. So, kaya siya tinatawag na moment of inertia with respect to y-axis. So, that is yung ix tsaka iy. Okay? So, I hope I made myself clear with that. Ma-encounter nyo to sa mga future subjects nyo. Very important si ix tsaka si iy. So these are the equations for moment of inertia for basic shapes. And again, itong moment of inertia na ito, itong equations na ito, it is yung reference point natin ay yung yung centroidal axis natin. So for rectangle, yung moment of inertia na yan with respect dito sa ating centroid. At ganoon din sa triangle, yung moment of inertia na ito with respect dun sa x-axis na horizontal na ito that lies along its centroidal center of gravity. Ganun din dito sa circle, sa centroid niya, semicircle sa centroid niya, x and y, quarter circle, centroid niya, x and y, ellipse sa centroid niya. Okay? So, moment of inertia with respect to x for rectangles, that is bh cubed over 12. Okay? For triangle, bh cubed over 36. Pag yung rectangle natin nakahiga, ang gagawin lang natin ay hb cubed over 12. Ganun lang yung fix natin sa moment of inertia. Okay? Proceed tayo. Please excuse me for a moment. Okay. That is yung moment of inertia with respect to its centroidal axis. Now, there are cases kung saan kailangan nating kumuha ng moment of inertia with respect to an axis na malayo but parallel dun sa kanyang centroidal axis. Okay? So, very important to sa built-up beams. For example, yung I-beams tapos meron tayong plate sa taas niya. Makita nyo yun later. So if the moment of inertia with respect to one axis is known, the moment of inertia with respect to another axis parallel to the first can be calculated from the parallel axis theorem, also known as transfer axis theorem. So transfer axis theorem because yung moment of inertia natin, tina-transfer natin to another parallel na axis. So for example, we have this beam, okay? We have this beam, tapos yung centroidal axis niya ay andito. Ito yung center of gravity niya. Ngayon, pagka kinukuha na natin yung moment of inertia with respect to this x-axis, so mamapansin natin, hindi na siya naka-align dun sa centroidal axis niya, but it is parallel to that centroidal axis. So yung equation natin would be Ix is equal to yung Igx. Ito yung moment of inertia with respect to its centroidal axis. Tapos kailangan nating idagdag yung transfer natin. So A, which is yung area, times yung D squared, which is yung distance ng transferred axis natin. So D, in this case, yung distance D na yan ay ito. Distance ng centroid, okay? So distance ng transferred axis niya from the original axis. Okay, so this will now be yung D. Okay? So, IGX plus AD. Ganun din sa Y, IY is equal to IGY plus AD squared. Ang kailangan lang nating maging careful sa paghanap ng value ng D, kailangan lang natin maging careful sa paghanap ng value ni D. Okay? So, transfer axis theorem. Okay, so as an illustration for transfer axis theorem, we have this figure. We have this cross-section, 500 by 250 millimeter beam or cross-section. Tapos yung kukunin natin yung moment of inertia niya with respect to this x-axis right here. Okay? So again, by transfer axis theorem, dahil nga yung center of gravity natin, yung axis pala natin ay tinransfer natin far from the center of gravity, kaya gagamitin natin yung transfer axis theorem. Okay, so Ix is equal to Igx plus AD squared. So we have BH cubed over 12. That is yung moment of inertia ng ating cross-section with respect to its centroidal axis plus yung AD squared dahil nga tinransfer natin. So si D natin would be yung distance ng transferred axis natin. So D. Okay, so that is yung equation natin. Mga variables natin given naman lahat. So let us solve for Ix. So we have B, yung base natin ay 250 millimeters, yung H natin ay 500 millimeters all over 12. And then, idadagdag lang natin yung AD squared natin. So A, yung area natin, we have 250 by 500. Tapos si D squared natin, 500. Tapos divide lang natin by 2. That would be yung value natin ng D. So we have 250 squared. Okay? So again, centroid ng ating cross-section ito. Kaya 500 divided by 2. So 250 squared. And using our calculators, we will get the value for Ix na. Please pull out your calculators. $500 cube over 12. So yung value ng moment of inertia natin with respect to this x-axis ay equal sa 1.0417 times 10 raised to 10. At ang units natin ay millimeter raised to the 4th. Okay? So, mapapansin naman natin dito sa equation natin, h cubed, so millimeter cube, times b ay millimeter, so millimeter to the 4th. At ganun din dito, AD squared, so D squared, magiging millimeter squared. Area natin, naka-millimeter squared, so we have millimeters to the 4th. So this will now be yung answer natin. The moment of inertia with respect to this x-axis. Okay? So in many cases, especially sa steel design, you will be getting yung moment of inertia of built-up beams. At madalas yung magagamit itong transfer axis theorem. So, common error to sa paghanap ng moment of inertia, yung nakakalimutan nilang idagdag yung transfer axis na AD squared. Okay? So that is yung for transfer axis theorem. So polar moment of inertia, hindi na tayo tatagal dito kasi na-discuss natin to sa discussion natin regarding torsion. So we have polar moment of inertia is equal to r squared times yung differential area, where r is equal to yung radial distance natin ng differential area na yan from the point of rotation or center of rotation. So that is just equal to integral of x squared plus y squared of the dA, differential area. Okay? Where yung pagka dinistribute natin si dA tsaka si dy dito, okay, pag dinistribute natin si dA kay x squared tsaka kay y squared, si x squared dA ay yung moment of inertia natin with respect to y, si y squared dA ay moment of inertia with respect to x. So, in cases kung saan hinahanap sa inyo yung polar moment of inertia ng any section, kukunin nyo lang yung ix tapos iy tapos ipag-add nyo lang siya, yun na yung polar moment of inertia niya. Okay? So, this in cases kung saan maka-encounter kayo ng problem na ang dami-daming pinapahanap. Tapos sa dulo, what is the polar moment of inertia? So, nahanap nyo na si Ix, nahanap nyo na si Iy, ipag-aan nyo lang silang dalawa. Okay? So, polar moment of inertia, it is the ability of the area to resist torsion or twisting. Okay? Yan yung na-discuss natin sa torsion, discussion natin sa torsion in the past. Okay? So, radius of gyration, pang-anim na property ng area is radius of gyration. So, it is an imaginary distance from the centroidal axis at which the entire area can be assumed to exist without affecting the moment of inertia. Okay? So, as a visualization, meron tayo ditong cross-section, tapos meron siyang equivalent na itong cross-section na ito, meron siyang equivalent na moment of inertia. Ngayon, yung sinasabi natin radius of gyration is this radius or distance. Kung saan, itong area na ito, itong original area natin na ito, gagawin natin siyang strip, tapos, i-place natin siya in a way kung saan yung moment of inertia niya from this same axis ay equal sa original na shape natin. Okay? So, ano yung radius na yun? So, that is yung radius of gyration. That radius of gyration that will cause this equivalent area strip to have the same moment of inertia as the original figure or original shape. Okay? So, the radius of gyration R is equal to yung square root of I over A. Okay? So, kung mahalo natin si moment of inertia, makukuha na natin si radius of gyration. Alam naman natin si area. So, makukuha natin si radius of gyration. So, yan lang yung basic na equation. So, for Rx, pag Rx to, Ix din to. Pag Ry, Iy din yung gagamitin natin. Okay? So, radius of gyration. And lastly, section modulus. So, the section modulus is simply the moment of the ratio of the moment of inertia of a section about its neutral axis to the maximum distance of its most extreme fiber from the neutral axis. So we have S is equal to I over C, where C is yung distance of the most extreme fiber from the neutral axis. So when we are considering yung X, so pag hinahanap natin si SX, IX, tsaka CX, So, ibig sabihin, ang kino-consider natin na C ay yung distance ng most extreme fiber from the x-axis. So, for example, ito yung x-axis natin, yung most extreme fiber natin ay ito. Because this is the farthest fiber or the farthest element from the x-axis. So, yung CX natin, yung distance niya from the neutral axis. Okay? At ganun din sa pagka pag CY naman yung hinahanap natin, pag yung reference axis natin ay Y. So the most extreme fiber when considering yung Y axis natin would be these points, these elements. Okay? Yung mga element na yan. Because yan yung pinakamalayo sa ating Y axis. So, yan yung magiging distance na i-consider natin when getting the section modulus. So, CY. Okay? So, please take note of that kasi later baka lumabas yan sa problems nyo. But anyways, direct substitution lang naman. Given naman yung mga dimensions. Okay? So, siguro magkakamali lang kayo sa pagkuha ng moment of inertia. So, very careful kayo sa pagkuha ng moment of inertia because yung radius of gyration, section modulus, and even yung maximum bending stress would depend kung tama ba yung moment of inertia natin or mali. So, that is yung preliminary discussion natin for the properties of areas. So siguro practice lang for getting the centroid or locating the centroid of of areas. So we have this figure. Meron tayong 2 by 2, 2 by 8, 4 by 8 na block. Tapos meron tayong mga butas na square dito tapos half circle dito. So we are asked to locate the centroid of the area shaded as shown. So itong shaded area na ito. Okay? So yung approach natin, meron tayong equation for the total in getting the centroid. So meron tayong area total, area 1, area 2, area 3. So let us call this area as yung area 1 natin. So area 1 natin, that is 4 by 8. Okay? And then yung area 2 natin, we will set this as area 2, yung square natin na butas. At yung area 3 natin ay yung half circle na butas. Okay? And then yung mga areas na yan, meron siyang respective na centroids. Okay? Tapos ang magiging reference point natin in solving this in solving the centroid ay itong point na ito. Let us use this as our reference point. Okay? So si x bar, that would be yung x distance ng centroid ng buong figure na ito. Tapos x1 natin ay yung x distance ng centroid ni A1. Tapos yung x2 ay yung x distance ng centroid ni A2. At yung x3 natin ay yung x distance ng centroid ni A3. Okay? So, ganun din yung in this case pagka yung area natin ay butas, yung sign natin magiging negative. Okay? So, in this case, so yung area 1 natin, yan yung original shape natin. Tapos, bubutasan natin ng A2 tsaka A3. Kaya yung A2 natin naka-negative, A3 natin ay naka-negative. Para maging tama yung makuha natin sagot. Okay? At ganoon din yung gagawin natin for getting the y distance ng ating centroid. Okay? So, A1, Y1 minus A2, Y2 minus A3, Y3. Okay? So, first order of business, solve natin yung total area. So, total area is equal to yung 4 by 8. So, this rectangle, we have 2 meters plus 2 meters equals 4 meters. Tapos 4 meters plus 4 meters, 8 meters. So, we have 4 by 8. Tapos, ibabawas natin yung mga butas. So, we have 2 by 2. Tapos, ibabawas natin yung half circle. So, area ng circle, pi r squared. So, pi, yung radius natin ay 1 meters. 1 meter. Tapos, squared. Tapos, dahil half circle lang, kakalahati natin. Okay? So, therefore, yan na yung magiging total area natin. So, this is yung area 1. Ito yung area 2. Tapos, ito yung area 3. Okay. So, very, very basic pa lang siya. Getting the areas lang naman siya. So, solving for x bar. So, we have 80. Or yung area total, x bar is equal to A1, x1 plus A2, x2 plus A3, x3. Okay? So, yung mga distances na lang yung kailangan natin i-determine. So, area 1 natin, 4 by 8. Tapos, yung x distance ni area 1 from the reference point natin. Again, yung reference point yung reference point natin ay itong point na ito. Okay, this will be yung reference point natin. And makikita natin na yung A1 natin ay yung centroid niya ay naka-align dun sa ating reference point. So therefore, yung x distance niya ay 0. X distance ng centroid niya. Okay? So negative yung A2 naman tayo. So A2 natin ay 2 by 2. Tapos yung centroid niya ay meron siyang centroid dito. Hahanapin natin yung x distance ng kanyang centroid. So, the x distance of the centroid from the reference axis is equal to itong distance na ito. Okay? So, the x distance, so if this is 4, this is 2, ito ay 1, ito ay 1. Tapos yung center niya, nasa gitna lang din. So, 1 ito, 1 ito. So, yung x distance natin ay 2. Okay, 1, 2. And then, dahil nga nasa left side siya ng y, or ng reference axis natin, we will set that as negative 2. Okay? So, sinusunod pa rin natin yung rules ng Cartesian plane system kung saan pag nasa left side na ng y-axis, mga negative values na yun. Pag nasa right, positive. Pag nasa baba ng x-axis or nung reference axis natin, negative na din siya. Pag nasa taas, positive. Okay? So, yan yung mga ano. And then, negative A3. Yung A3 natin ay 1/2 ng pi r squared. Tapos, yung distance ng centroid niya ay the same lang din, 2. So, visualize lang natin ano yung centroid niya siguro nandito sa gitna. Tapos, hanapin natin yung x distance niya. So, x distance niya, that would be this distance. Okay? So, if this is 4, if this is 2, therefore, itong mga points na ito, mga lengths na yan ay 1, tapos sa gitna niya, tapos 1 ito, 1 ito. So, therefore, yung x distance ng centroid niya ay 1, 2. So, 2 meters lang din. Okay, so 2. And then, all over yung total area na 4 by 8 minus 2 by 2 minus 1/2 pi r squared. Using our calculators, we will get yung value na 4 by 8, 0, 2 by 2 by negative 2, 0.5. Someone from the group, na-solve nyo na ba? All over napalabas nyo, 0.1838. This will now be yung x distance ng ating centroid from the reference point natin na O. So, 0.1838 and yung units niya ay naka-meters. Okay? So, that is yung x distance natin. Let us now solve for the y distance. Now, solving for y distance, kailangan natin munang determine yung y distance ng centroid ng ating half circle. Dahil nga, hindi naman ganun ka-common na meron tayong half circle na hinahanap. So, hanapin muna natin yung centroid ng half circle. So, for half circles, ito yung magiging centroid natin. Okay, yung value ng centroid ng half circle natin is given by the equation 4r over 3 pi. Okay? So, substituting yung given. So, yung y bar na tinutukoy niya dyan sa equation natin would be this y bar right here. Okay, yan yung y bar natin. At yung y3 natin would be this distance, y3. Okay, so let us solve for yung y bar. Tapos hanapin na din natin si y3. So, solving for y bar, that is 4r is equal to 4 times yung radius natin. Radius ng circle natin ay 1 meter. All over 3 times pi. Okay? Getting your calculators, yung value ng y bar natin ay 0.4244. Okay? So, yung y bar natin, 0.4244. Okay? So, yan yung ano natin, y bar natin. So, yung y3 natin, ibabawas lang natin yung y bar sa 4 meters. So, 4 meters minus 0.4244, that would give us the value 3.5756. Okay, so 3.5756, that is in meters. Okay, so wala na tayong problema, nahanap na natin si y3, we can now solve for y bar. Okay, solving for y bar, yung equation natin kanina, 80 y bar is equal to a1 y1 minus a2 y2 minus a3 y3. Okay, so getting an equation for y bar, a1 y1 plus minus a2 y2 minus a3 y3 all over yung total area. And substituting yung mga values natin. So area 1 natin, that is 4 by 8. Tapos yung y distance ng centroid niya from the reference axis natin, reference point natin. So again, ito yung reference point natin. Okay, so yung y distance ng ating centroid ng y1, that is 2 meters. So we have 2 dito. Minus yung area 2 natin, 2 by 2. Tapos yung y distance ng centroid niya. Okay, so if this is 2, ibig sabihin yung centroid niya ay nandito. Okay, so 2 plus 1, that would give us 3. Again, nasa lahat ng y distances natin nasa taas ng x-axis. So, lahat ng y distances natin ay positive. So, negative, yung a3 natin ay 1/2 pi r squared. Tapos yung y3 natin, yung nasolve natin kanina na 3.5756. Okay, all over yung total area na 4 by 8 minus 2 by 2 minus 1/2 pi r squared. Okay? So solving solving for this value ng y bar, makukuha natin yung sagot na 4 by 8 by 2 minus I 3.5756. Someone from the group na palabas yun, ha? 22 minus 4. Sagot natin ay 1 point y bar is equal to 1.755 meters. So this will now be yung location, y distance ng centroid ng buong shape natin from the reference point natin. Okay? So kung i-sketch natin yan, this would be the location of our center of gravity, where yung y bar natin would be this one right here. Ito yung y bar natin. Tapos yung x bar natin will be this distance right here. Ito yung x bar natin. Okay? So x bar natin 0.1818 something, tapos y bar natin ay 1.755 meters. So that is yung solution for sample problem number 2, locating the centroid. Very basic. Punta tayo sa medyo mas mahirap naman. In this case, it is a problem na binigay nung past board exam. So this is a past board problem. So from November 1993, so meron tayong T-section. T-section is made up of 30 millimeters by 100 millimeters flange and a 30 millimeter by 160 millimeter web. So pag sinabi nating web, pag dating natin sa beams, okay, yung mga web natin ay yung mga vertical members natin. So mapapansin natin itong vertical member natin na ito, siya yung 30 by 160 millimeters. So, determine the properties of the section. Hanapin natin center of gravity, moment of inertia, tsaka radius of gyration. Okay? So, that is yung mga kailangan nating hanapin. Okay? So, diretso tayo sa solution natin. Center of gravity. Para mahanap natin sa center of gravity, i-assign muna natin ito as yung area 1 natin with its centroid located here. So, yung mga centroid natin ay naka-align sa y-axis natin. Okay? And then yung pangalawang area naman, we will call this area 2. Tapos yung centroid niya ay andito. So yung centroid niya naka-align siya sa y-axis. So hanapin na lang natin yung x bar natin. I mean yung y bar natin kasi yung mga x distances niya ay naka-align naman sa y-axis. Okay? So finding the center of gravity, very basic. So area total y bar is equal to a1 y1 plus a2 y2. So nagdadagdag na lang tayo dito. At yung magiging reference point natin ay itong top ng beam natin. Okay? So, yan yung magiging reference point natin. So, finding the center of gravity, we have this equation. Let's proceed sa sa solution natin. So, let us determine y1, let us determine y2. So, y1, that is equal to, yung y1 natin, kalahati lang ni 30 millimeters. Tapos, si y2 natin would be this distance. Kukunin natin yung kalahati ni 160. Tapos, idadagdag natin 30 millimeters. So, that would be yung y2 natin. And syempre, yung centroid natin, o yung center of gravity ng beam natin, okay, ng overall beam, ay located dito, somewhere here. That is yung y bar natin. So, solving for y bar muna tayo. Okay, so y bar is equal to a1, y1 plus a2, y2 all over yung total area. Okay, so area 1 natin, 150 by 30. Okay, and then yung y1 natin ay 30 divided by 2, that is 15. Okay, plus area 2 natin, that is 30 by 60. 30 by 160, I should say. Sorry, and then yung centroid natin, center niyan from the centroid ng area 2, from the reference line natin would be yung 160 divided by 2, that is 80. So 80 plus yung 30 millimeters na length na ito. So 80 plus 30, that would be 110 millimeters. And then all over yung total area natin, summation lang ng dalawang areas. So area 1 na 150 by 30 plus area 2 na 160 by 30. Okay? Using calculators, nakuha natin yung sagot na 150 by 30 by 15. All over. Okay, so yung sagot natin ay 64.0323. So, store natin yan sa A. So, check natin kung na-store na 64.03. Okay, so yung y bar natin would be 64.03 millimeters. Naka-store to sa A, para yung sagot natin hindi ganun kalaki yung error natin. Okay, so this is yung y bar natin. Nasolve na natin si y bar. We can now solve for the nahanap natin center of gravity. Because yung x bar natin ay nandito lang din sa gitna ng ating cross section. Okay? So this will now be yung sagot natin for the first problem, finding the center of gravity. Y bar is equal to 64.03 millimeters. Okay? So next part ng problem natin, finding the moment of inertia naman. So nakuha na natin yung centroid natin, yung center of gravity natin na 64.03. Let's find yung moment of inertia naman. So again, ang gagawin natin, we will get yung moment of inertia ni A1, tapos moment of inertia ni A2, tapos ipag-add lang natin. Okay? So, excuse me. So, dahil nga ang kukunin natin ng moment of inertia with respect to its neutral axis, so ito yung neutral axis natin, So mapapansin natin na si area 1 ay may yung centroid niya may distance from the neutral axis. So therefore, gagamitin natin dapat yung transfer axis theorem. So Ix ng A1 tsaka Ix ng A2, tapos ipag-add lang natin silang dalawa. Okay? So dahil nga gagamit tayo ng transfer axis theorem, kailangan natin malaman yung distances ng mga centroids na yan, centroid ni A1, ni A2 from the neutral axis. Okay? So kailangan natin i-solve si D1, kailangan natin i-solve si D2. Okay? Solving for D1 and D2, okay? Very basic algebra na lang yan. So, para ma-solve natin si D1, kukunin natin si 64.03 or si Y bar, tapos ibabawas natin yung kalahati ni 30 millimeters. So, 64.03 minus 15 or yung kalahati ni 30 millimeters, that would give us a value for D1 na 49.03 millimeters. Okay? Very basic job lang yan. Okay? Now, solving for D2 naman. For D2, kukunin natin yung value ni Y2, tapos ibabawas natin si Y bar. Okay? So, Y2 minus Y bar. So, yung Y2 natin, yung ginamit natin kanina, yung kalahati ni 160 plus 30 millimeters, that is 110 millimeters. Tapos ibabawas natin si Y bar na 64.03 millimeters. So we have yung value ni dito na 45.97 millimeters. Okay? So, yan yung values ni D1 tsaka ni D2. Paki-check na lang later pagka nagre-review kayo para ma-confirm nyo kung tama yung mga values ni D1 tsaka ni D2. Okay? So, please excuse me for a moment. Okay, continue tayo sa solution natin. So we have now D1 tsaka D2. We can now solve for the moment of inertia. Okay? So Ix is equal to Igx plus AD squared ng area 1 plus Igx plus AD squared ni area 2. Kaya meron tayong subscript na 1, meron tayong subscript na 2 dito. Okay? So, focus muna tayo sa area 1. For area 1, Igx natin, BH cubed over 12 plus AD squared. Ayan yung sa area 1 plus IGX, BH cube over 12 plus AD squared ng area 2. So, ganun lang kasimple. Tapos, focus muna tayo sa area 1 and then we add yung area 2. So, area 1 muna tayo. So, for area 1, yung base natin ay 150 millimeters. Tapos, yung height natin ay 30 millimeters. Tapos, i-cube natin yan. BH cube all over 12. And then, yung transfer axis theorem natin na AD squared. So, area natin na 150 times 30. 150 by 30. Tapos, D squared. Yung D squared natin ay yung distance ni centroid from the parallel axis. So, yung distance na ito, which is yung D1. Okay? So, D1, that is equal to 49.03 millimeters. Tapos, i-square lang natin. So, that is yung moment of inertia natin with respect to x considering area 1. Okay? Plus, yung area 2 naman tayo. So, we have yung base ng ating area 2, that is 30 millimeters. Tapos, yung height natin ay 160. So, 30 times 160 cube. So, BH cube all over 12. And then, yung transfer axis theorem natin. So, we have 160 times 30 millimeters. Yan yung area natin. Tapos yung distance ng centroid to the parallel axis, which is D2. So yung D2 natin ay 45.97 millimeters. So 45.97 millimeters, naka-squared. So ito na yung moment of inertia with respect to x natin for area 2. Okay? And then, i-summation na lang natin using our calculators, makukuha natin yung answer natin for moment of inertia with respect to x. So, with respect to x na tayo. So, 150 by 30. Please do this din sa mga calculators nyo para makasunod kayo. Anyone from the group? Palabas nyo na yung sagot. Okay. 31,538,790. Ang unit niya ay millimeter raised to the fourth. Hindi ko palabas sa calculator ko, pero tama yan. Yan yung, yung moment of inertia with respect to x for this particular uh, cross-section. So that is yung first part now mo finding the moment of inertia natin. Okay? So that is yung with respect to x. Ngayon, syempre, kailangan na natin i-consider yung moment of inertia with respect to y. So finding the moment of inertia with respect to y. So we have igx plus ad squared for section 1. Yan yung equation natin yung nauna. So for getting the moment of inertia with respect to y, so we have iy is equal to igy ng section 1 plus igy ng section 2. Okay? So bakit hindi na tayo nagkaroon ng transfer axis? Because yung mga yung y-axis ng ating area 1 tsaka area 2 ay nagko-coincide sa y-axis ng ating whole section. Okay, so si area 1 saka si area 2, yung mga y-axis niya ay nagko-coincide dun sa neutral axis ng ating cross section. Kaya yung d natin, imbes na pag magta-transfer axis tayo, yung mga d natin magsi-zero siya. So pag nag-zero si d, yung AD na yan may mawawala. Kaya may iwan yung IG na lang, yung moment of inertia with respect to the centroidal axis. Okay? So getting the moment of inertia with respect to y, so bh cube, hb cube over 12 dapat to hb cube over 12 plus hb cube over 12 ng section 1 plus hb cube over 12 ng section 2. So substituting the values, yung h natin, bh cube bh cube over 12, so 150 hb cube over 12 pa rin siya, okay? So hindi ko na ilipat yung yung cube. So ayusin ko lang sa PowerPoint para hindi maano yung flow ng lecture natin. Okay? Hindi na siya maayos sa sa PowerPoint, kaya tanggapin na lang natin ayusin ko na lang pag in-upload ko tong lecture na ito. So this should be hb cube or b cube h over 12 plus b cube h over 12. So yung base natin na 150 for area 1, 150 cube times 30. B cube h all over 12. Tapos yung b cube h din ng area 2. So area 2 natin, so yung base niya ay 30 millimeters naka-cube times yung h niya na 160. Okay? So all over 12. So therefore, makukuha natin yung moment of inertia with respect to y na so yung moment of inertia with respect to y, that is 8,797,500 millimeter raised to the 4. So this will now be yung moment of inertia natin with respect to y. Okay? So, yan na yun, yung part 2 ng ating solution, yung finding moment of inertia. Now, let us go to yung third part, which is yung finding the section modulus. So, to find the section modulus, meron tayong equations, Sx is equal to Ix over Cx, or S is equal to I over C. Okay? Where C is yung distance of the most extreme fiber to the neutral axis. Okay? So, hanapin muna natin si Cx. Okay? So, si Cx natin, it can be 64.03 or this distance. Okay? Or this distance. Okay? So, 64.03. So, this is 190 minus 64.03. Okay? So, syempre, ang pipiliin natin yung pinakamalayong fiber from the neutral axis o from the x-axis sa center of gravity. Okay? So, therefore, yung Ix natin, 31.538, 790 millimeter raised to the fourth all over yung Cx natin. Yung Cx natin, yun nga, pipili tayo sa dalawang distances na ito. Where yung first distance natin ay si y bar natin na 64.03, tapos itong longer distance na ito ay 190 minus 64.03. At syempre, kitang-kita naman sa figure na mas mahaba itong part na ito. So, yung length na ito ay 190. So, 160 plus 130, that is 190, minus yung y bar natin na 64.03. So, inputting sa calculators natin, we will get yung sagot na 250,367.4684 millimeter to the millimeter cube. Okay? So, this will now be yung section modulus natin. So, yung units natin, millimeter to the fourth divided by millimeters, may iwan ay cubic millimeters. So, this is not volume, but section modulus. And ganun din pag SY. So, getting the section modulus with respect to y. So, IY times IY over CY, where yung CY natin ay yung distance of the most extreme fiber from the y-axis naman ang reference natin. So, yung CY natin, so we have IY na 8,797,500 millimeter raised to the 4 all over yung CY natin na 75 millimeters. So, 75 millimeters because yung distance ng most extreme fiber natin from the y-axis. So, this is the most extreme fiber. Tapos, ito yung y-axis natin. So, ito yung distance na ito, which is 150 divided by 2. Kaya, 75 millimeters. And inputting sa calculators natin, we will get yung value ng section modulus with respect to y-axis na 117,300 cubic millimeters. Okay? So, that is yung pagkuha ng section modulus. Okay? So, yun na yung first three parts. Yung three parts ng ating problem na tapos na natin. Konting continuation lang para makuha natin yung radius of gyration. Square root ng Ix over area lang. Okay? So, makuha natin si Rx. So, very straightforward. Apply lang natin yung equation. At ganoon din yung radius of gyration with respect to y. Okay? So, square root of Iy over a, we will get yung value na 30.7566 millimeters. This is yung radius of gyration with respect to x, radius of gyration with respect to y. So, yan na yung for radius of gyration. So, summary. As a summary, sa mga nakuha nating values. So, yung y bar natin or yung centroid natin, that is 64.03 millimeters. So, yung moment of inertia natin with respect to x, that is 31 million. Moment of inertia with respect to y, 8.7 million. Section modulus with respect to x, that is 250,000. Section modulus with respect to y, that is 117,000. Radius of gyration with respect to x, that is 58.2. Tsaka radius of gyration with respect to y, that is 30.8 millimeters respectively. So, this will now be yung summary natin pagka isusulat natin yung front page ng problem natin. Okay? So, that is yung solution natin for sample problem number 3. and that sums up yung lecture natin regarding yung properties of areas. Okay? So next next topic natin would be bending stresses or flexural stresses. So siguro 10 minutes lang 'yun, tapos na tayo sa lecture natin. But in the meantime, mag-break siguro muna tayo. 5 minutes break tapos tuloy natin yung lecture natin. Okay? So see you all. Ang time ko dito ay 2:32. So 2:37 resume tayo ng lecture natin. Okay? Thank you.